So today we're going to begin Unit 6. And Unit 6 is over rational exponential. Sorry, you made me laugh, okay? Today we're dealing with equations that have rational exponents, okay? And radical equations with radicals, okay? So equations with rational exponents and equations with radicals. Luckily for us, we've already talked about some of these things, okay? We've already kind of built the foundation. And so today is going to be a sort of review, okay? Today we're kind of just going to review those, refresh those properties and methods that we've learned. And so oh my gosh, where did I put the foldable? Alright, well the foldable we made, okay, the exponential foldable has all the colors and flaps. Alright, that's going to come in handy again. Alright, that's going to be our best friend. So whenever we forget these things, we can always refer back to that. You guys know what I'm talking about? Yes. Alright, good. Okay. So today is just going to be review, and then towards the end there will be something that's a little bit new. Alright, something that we haven't really talked about. Okay, so to begin, right here we have an integer, okay, or a whole number with the rational exponent. Alright, now we could always, alright, if we wanted to figure out what this value is, we could always just plug this whole thing into our calculator. Alright, we'd say 8 and we'd hit the caret symbol and then do 1 divided by 3 and we could find out what that is. Alright, now if you don't have a calculator, we can still figure it out. Okay, do you guys remember when we have a exponent that's a fraction, do you guys remember what the numerator represents, what operation the numerator is? Do you guys remember? Starts with the P. Power. Very good. Okay, so if we have a base, we have a rational exponent, the numerator, that operation is the power. Okay, and the denominator is the, what operation is that? I think I heard someone whisper it. No. What operation is the denominator? The denominator starts with the R. This is the power. What's the opposite operation of root? Thank you, root. Okay. And if you think about a tree, the root is on the, where are the roots? The bottom. Okay. So we know if we have a rational exponent, the numerator is the power and the denominator is the root. So here we can figure out this, find this value by doing one before the other. So doing the power first or doing the root first. Typically you want to break it down and then go back up. So if we have this 8, we'd want to take the root first. Okay, so what's the cubed root of 8? You guys remember what the cubed root of 8 is? What times what is 8? 2. Okay, and then 2 to the first power is what? 2. Okay, and we're doing this without a calculator, this part here. So now if we're going to do this one, if we were to do the power first, do any of you guys know what 81 cubed is? Could y'all do that in your head? I mean, yeah, you probably could, but it would take a very long time. I mean, for me, it would even take a long time. So what we're going to do is we're going to do the root first. So what's the fourth root of 81? What times is 81? 3. Very good. It's 3. 3 times 3 times 3 times 3 is 81. Okay? So now we still have this power left. Okay? So what's 3 cubed? 27. Okay, so we have 2 for this one, 27 for this one, and then here it's the same idea. We want to take the root first. Okay, so if we take the root first, what's the square root of 25? 5. Okay, and then what's 5 cubed? Still have the cubed root power left. What's 5 cubed? Well, 5 times 5 is 25. Yeah, and 5 times 25 is 125. Okay, yes. So the main reason I want to show you guys this is, one, if we ever do not have a calculator, we can figure it out by doing the operations one at a time. And also, just to remember that when we have a rational exponent, the numerator is the power and the denominator is the root. Okay, you want to keep that in mind. Those are things that we have to know. Okay, and all of this is in your foldable. Okay, the little exponential and radical foldable we made. Alright, the next thing we're going to look at, or we're going to review over, it's kind of the same concept. Okay, now understand what we just talked about. Let's match this expression here with its corresponding letter. Okay, so could somebody tell me what letter goes with this based off what we just talked about? The numerator being the power and the denominator being the root. Okay, so we have B and D. Okay, so here if we look at B, 4 is the power. Okay, well here 4 is the power and 3 is the root. 3 is in the denominator, 3 is the root. So which one is it? B. Okay, so now let's look at the second one. Which one? D. Okay, yes, 3 is the power, 4 is the root. So the second one goes with D. Now, see if you guys can get this one. A. Why is it A? Very good. Okay, good job. Y'all are the first group that got it today. This negative sign tells us, if we remember, when we have a negative exponent, that we're doing the opposite operation. So instead of multiplying, okay, we're now dividing. So we can put this in the denominator. And so this expression here is A. Okay, this is A. So normally if we had 5 squared, it'd be 5 times 5, right? We're multiplying. Well, anytime we have a negative exponent, that's when we do the opposite, we divide. So we can write that in the denominator as the 4th root. Okay, now this one is obviously the last one, so it's C. And the reason why this negative doesn't necessarily affect anything is because it's on the outside. So that negative just stays on the outside. And then this 1/4 is the 4th root, so we just write it as a root. Okay, as a radical. Does that make sense? Okay, so the biggest thing here, concept that we need to understand, is that the radical versus an exponent, it's just a different way of writing the same expression. They both are equivalent. Okay, we can just write them 2 different ways. We can write it as a radical, or we can write it as an exponent. Okay, so now, alright, do a very quick and easy example. Okay, this is something we've done before. We solved radical equations. Alright, this is just to kind of refresh the process. Okay. So we have, let's do x. Okay. So we have this expression here. I mean this equation. Alright. What were the 4 steps? Isolate. Get rid of. Solve and check. Okay. So the first step is to isolate the radical. Second step is to get rid of the radical. Third step is to solve. Fourth is to check. So here is the radical isolated. No. So you want to do what? Add 4. Okay. So now you have the square root of x equals 4. Now what? Yeah. So we want to get rid of the radicals. So we want to do the inverse operation. So square it. So we get x equals, and 4 squared is 16. And then we check it. Okay? So the square root of 16 is 4. 4 minus 4 is, so it works. Okay? So that's what we did. Alright? And we did equations that were a little more difficult. Okay? You guys were already tested over that. And so not going to spend a whole lot of time reviewing those. Okay, you could always just look back to previous homework or quizzes or tests. But this is we've solved radical equations. Okay, today the difference is the new wrinkle that we're throwing in are equations with rational exponents. Okay, so instead of a radical, we're going to have a rational exponent. What did I do with my paper? Is there an orange piece of paper up there? Can you bring it here, please? Thank you. Thank you. Alright, so now we'll see something like this. Okay, so now we want to start taking notes. Alright, this is the part we need to take down. Excuse me? What's notes? Like what are notes? Notes? Notes are when you write down examples and information that's going to be important to you later. Okay? Alright, so now, based on what we talked about, this part here could really be, or can be written also as this. Okay? If we were dealing with the radical, this part here, we could substitute this in for that. These are equivalent. Okay. Well, I'm just talking about this part here. Okay. So knowing that, we can treat this the exact same. We can use those same 4 steps. Okay. So instead of the radical, we're just going to look at the part with the exponent. All right. So we want to isolate the part with the exponent. Yes. Oh yeah. This is in parentheses, by the way. Okay, so yes, the first thing we have to do is to isolate, so we got to add 2. Okay, add 2 to both sides. So now you have 3x, parentheses, to the 3/4 power equals 27. Okay, so now the second step was to get rid of. Alright, so now we want to get rid of this exponent. Okay, the thing about rational exponent is that there's 2 operations. We're taking it to a power and the root. Okay, so the way that you do this, okay, I'm going to tell you how and then kind of go backwards and explain why. the way that you do this is by raising it to the reciprocal. Alright? So what would the reciprocal of 3/4 be? 4/3. Okay? Reason being is that if you raise, so via scratch work, if you raise this 3/4 to 4/3, okay? I mean, if you raise 3x to 4/3, kind of. Yeah, just, we'll see. It's it's a little bit different. Yeah. Okay, so now, what's 3 times 4? And what's 4 times 3? So that is 12/12. Well, what's 12/12? 1. And what's 3x to the first power? It's just 3x. Okay? So, by raising this, okay, this 3x to the reciprocal, you eliminate the exponent. Okay? You make the exponent 1. Alright? And anything to the first power is just itself. Does that make sense? Okay? Because when we were squaring it, when we had a square root, we had the square root of x, right? We would square this. We would square it to undo the radical. Alright? Well, that was really, the square root of x is the same as x to the 1/2, right? Well, if we squared that, we're multiplying, and really what we were doing was getting x to the first power the whole time. Alright, so that's the only thing that's really changing. Is to get rid of the exponent, all you have to do is raise the base to the reciprocal. So here, if we were to do this, we'll raise it. And what you do to one side, you have to do to the other. Okay? So now this 27 is raised to 4/3. These multiply to 1, so we get 3x equals and now if you have a calculator, you can just plug this in. Alright? Just plug this into your calculator and solve that way. Or if you do not, we can do what we did earlier. Okay? We can do the root first. Alright, do the operation separately. So 27, the cubed root of 27 is 3. Okay? Cubed root of 27 is 3. And then we have the power 4 left. So 3 to the 4th power is 81. Very good. Okay? So that's how you can do it without a calculator. When in doubt, you can always use a calculator at that part. Okay? So now, what's the last step? Yeah, divide by 3. So you want to solve for x. We're on step 3. You want to solve for x. I apologize, that's the second to last step. Okay, and what's 81 divided by 3? 27. Okay, and so we found an answer. We now just have to check it. Okay, so what you would do is you plug in 27 in for x. Alright, and see if this equation is true. Okay, 3 times 27 is 81, and 81 to the 3/4, I believe, yeah, it's 27. 27 minus 2 is 25. 25 equals 25. So this works. If you don't believe me, you could always plug it into your calculator. Alright? So it's the same thing. We're following the same steps. Okay, so it's new, but it's not new. But instead of working with radicals, we're now working with rational exponents. And so to get rid of those rational exponents, all we're doing is raising to the reciprocal. Okay? Raise the base to the reciprocal. Alright, so now Okay. I'm not going to work out because at this point, does this make sense so far? Are you guys okay? So at this point, a lot of the classes have just been starting their homework, but there are certain things that every class runs into. So I'm gonna just kind of like touch on those. This is not gonna be your homework, but stuff that's similar. So if you have, let's see, if you have something like this. Okay, yes. And I say this equals 4. Okay, if you start off with this, okay, and we're solving, all right, we first have to ask ourselves, or we have to isolate. So we have to ask ourselves, is this isolated? No? Why not? They're 2. Okay, the 2's in front. Okay, if there are no parentheses here, okay, the previous problem we had parentheses. If you look at your notes, so that whole piece was isolated because everything was raised to the exponent. Here, the only thing raised to the exponent is the x. Okay, so we want to isolate just the x and its exponent. This 2 needs to go to the other side. So what would we do? Yeah, we'll divide by 2. Since this is multiplication, we do the inverse operation, so we divide. Okay, that's one thing that you'll see. Okay, it's one thing you have to remember. What's the other? The other thing is something like this. Yeah. These divide to 1, and this would be 2 on this side. Okay, so here, all right, is this part isolated now? For this example, is this isolated? Yes, it is, because the part in the parentheses goes with the exponent. Okay, and there's nothing in front or behind, so it's isolated. So now, how would we? What's the next step? Yeah, so we get rid of it. Okay, so what's the reciprocal of 1/2? 2 over 1. So raise x plus 1 to 2 over 1. Okay, and then that's basically just squaring it, right? 2 over 1 is just 2. So this becomes x plus 1 equals x squared. Okay, all he did was raise both sides to 2. Okay, what you do to one side, you have to do to the other. And now we're at the point where we solve. We have an x squared. Okay, what type of equations do we get when we have an x squared? Close. I know what you're trying to say. Starts with the Q. Quadratic. So what we just covered. Okay, so anytime we have quadratics, what we want to do is we want to set it equal to 0 or move everything to one side. Okay, so here I'd move the x and the 1 to the other side, so subtract them from both sides. And the reason why you want to set it equal to 0 is that we can use the majority of the methods we talked about. Okay, so at this point, what I recommend doing, okay, you can use any method you want to solve. Alright, when you have a quadratic equation, you can use any of the methods we covered. But I recommend setting it equal to 0 and then either using the AC method, okay, either factor it or use the quadratic formula. Alright, the AC method works well when it's factorable and you can use the shortcut. Okay, our A is 1. I'd recommend using the AC method. And if for some reason you can't, or you have you can't use the shortcut, or it's not factorable, then go ahead and use the quadratic formula because it always works. Okay, that's what I recommend, but at the end of the day, whatever method works best for you, use that method. Okay, does that make sense? Alright, I think that's it. Yeah, this is completely different from this. Yeah, these are separate. I was just showing you some things that you might see in your homework. The only thing that was new today was just how to get rid of, okay, how to get rid of the rational exponent, okay. So all you do is just raise it to the reciprocal. All right. Okay. You guys have a good day.